Welcome to springlib.
In this problem, we simply want to determine the angular speeds of two spools at omega 1 and omega 2. Omega 1 has to be v over r, and omega 2 has to be this ugly mess. But don't worry, it's not that hard of a problem. So, first off, what we can determine is that the area between the start and the finish are constant at all points in time. You aren't losing any tape, you aren't gaining any tape. So what you simply can start with is you can start with your area at the start is going to be equal to pi RT squared minus pi RS squared. If you're wondering where I got that from, right here, RT is simply the radius of the tape from the center, and the RS is simply the radius of the spool itself. So all we're worried about right now is we're worried about how much area all of this tape here in green really encompasses. And that will slowly get transferred over into here and here. Looking at the second case, we have, let's look at the original spool first. So let's look at this one right here that I'm marking right now. This one has radius r after some time, so it's simply pi r squared minus the radius of the spool, so that's still there. And then some of that is going into here, but it's still not radius t yet. There is still some tape on this spool specifically, so it can't be pi rt, it has to be pi r2 squared. And then there's still a spool, so you still have to have pi rs squared. What you can see immediately is all of our pi's will cancel. Lovely. But then on top of that, one of our rs squared values will cancel out as well. So it could be the second one, it could be the last one, it could be whatever. So what ends up happening is you can end up seeing that we have RT squared is equal to R squared plus R2 squared minus RS squared. And from that, if you solve for R2, all you have to do is scoot this RS squared over, and you have to scoot this R squared over. What you end up finding is R2 is equal to the square root of RT squared plus RS squared minus R squared. Remember, RT is the radius of the tape, RS is the radius of the spool, and minus R is whatever amount of tape is left on the original spool. So, plugging it back in, we can see that when it's initially coming off the spool, when this tape is originally coming off this specific spool, it will be coming off at some angular speed v over r. But then on our second one, it's coming on with speed v, but it's not coming on with the radius r, it's coming on with this radius 2, RT squared plus RS squared minus R squared. So that's the first part done. When it comes to the second part, you simply have to look at your initial cases and see what's going on here. So, at the start, So again, this is at the start. This is when you have all of the tape on the first spool and almost none on the second spool. R equals RT, and R2, so that's the radius of the second spool, that's the radius of tape around the second spool, is equal to RS. So, looking at these two equations that we found, omega 1 becomes V over RT, and then our second equation, R2 simply becomes RS. So this entire bottom term becomes RS. So we get omega 2 is equal to V RS. These are the maximum speeds that both can achieve. At the end, so instead of it being like this, it will instead be like this. It's the exact same situation but reversed. So instead of omega 1 is equal to V over RT, it's going to be V over RS, and omega 2 is going to be V over RT instead of V over RS.